humanity first landed on the moon, the technology we had was quite primitive and poor compared to today. Both in terms of space technology and general world technology, we were far behind where we are now. Yet even back then, several manned missions to the moon were successfully carried out. So why is it that today, no state or private space agency sends manned missions to the moon? Could it be that something was discovered there that humanity was never meant to know? Or are secret missions to the moon still taking place without the public's knowledge? Today, dear friends, we'll be delving deeply into this fascinating topic together. From the space race between nations to the details of lunar missions, we'll cover it all. If you're ready, let's travel back in time and begin our journey to the moon. The mid-20th century witnessed one of the fastest scientific and technological leaps in human history. Right after World War II, the two superpowers, the United States, USA, and the Soviet Union, USSR, entered a competition that divided the world not only politically or militarily, but also in terms of technological prestige. The symbolic and most magnificent stage of this rivalry became the space race. And the pinnacle of this race was the night of July 20th, 1969, when humankind set foot on another celestial body for the first time. The psychological atmosphere of the Cold War turned space into not only a field of scientific curiosity, but also one of ideological superiority. In 1957, with the launch of Sputnik 1, the Soviets placed humanity's first artificial satellite into orbit. This small metal sphere sent shockwaves through the United States, because now the battlefield was no longer confined to Earth. Information, speed, and technology had become new weapons. Then in 1961, when Yuri Gagarin became the first human in space, the Soviets gained enormous propaganda superiority. The US responded with a bold goal: to send a man to the moon and return him safely to Earth. This goal was announced by President John F. Kennedy on May 25, 1961, during a speech before Congress. His now legendary words marked the beginning of a new era for NASA. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Founded in 1958, NASA, National Aeronautics and Space Administration, was initially designed as a peaceful scientific institution. But it soon became the strategic response of the US to the Soviet Union's Vostok and Luna programs. By the early 1960s, NASA had evolved into a massive organization uniting hundreds of thousands of engineers, scientists, and technicians. The Apollo program became the most expensive and complex engineering project in human history. The goal wasn't just to reach the moon, it was to redefine the limits of space technology, gather scientific data, and demonstrate American leadership to the world. At the heart of this effort stood the Saturn V rocket, still one of the most powerful rockets ever built. Height, 110 meters, about a 36-story building. Carried 3.5 million kilograms of fuel, produced 34 million newtons of thrust at launch. Behind this power was the vision of Wernher von Braun, a German rocket engineer brought to the US after World War II. Von Braun's engineering principles laid the foundation for manned spaceflight. Going to the moon wasn't just about building a rocket. The human body is extremely sensitive to space radiation, zero gravity, lack of oxygen, and temperature extremes. Moreover, the average 384,000-kilometer distance between the Earth and the moon pushed the limits of 1960s technology. To overcome these challenges, NASA developed hundreds of new technologies: miniature computer systems, Apollo Guidance Computer, pressurized space suits, A7L suits, Lunar Module, LEM, Lunar Excursion Module, telemetry and communication networks, heat-shielded re-entry capsules. Many of these technologies are still used today in aircraft, computers, and even medical equipment. Apollo wasn't just a space mission. It was the engine that drove modern science. On July 16, 1969, Apollo 11 was launched from Kennedy Space Center in Florida with 3 astronauts: Neil Armstrong, Buzz Aldrin, and Michael Collins. After a 4-day journey, the Eagle lunar module landed on the moon's surface, and Armstrong uttered the immortal words, "That's one small step for a man, one giant leap for mankind." This wasn't just an achievement. It became a symbol that made humanity question its place in the universe. The 21.5 kilograms of lunar rock brought back to Earth provided revolutionary insight into the moon's geological history. But above all, it proved that humanity could achieve the impossible. Although the official statement was scientific discovery, the Apollo program also had significant political and military objectives. Access to the moon also meant superiority in ballistic missile technology, communications, and global intelligence. The U.S. gained both technical and moral dominance over the Soviet Union. Between 1969 and 1972, a total of 6 successful lunar landings, Apollo 11, 12, 14, 15, 16, 17, were completed, securing America's dominance in space. But ironically, this very success marked the beginning of the end of the program. Reaching the moon had been a dream, but turning that dream into reality required an unprecedented mobilization of economics, engineering, and politics. The Apollo program, though seen as a heroic story on the surface, was in reality a massive system that pushed human limits, burned billions of dollars, and required thousands of people working day and night. The heart of the Apollo program was the Saturn V rocket, a 3-stage engineering masterpiece. At launch, the 3,000-ton giant used 5 F-1 engines, each producing 680 tons of thrust. When fired, they generated sound waves over 120 decibels, powerful enough to make steel structures vibrate on the launch pad. Designing these engines was nearly impossible with the computing power of that time. Many calculations were done by hand, and the computer simulations could only perform a few hundred operations per second. Even so, the rocket's stage separation mechanisms, fuel mixture ratios, and thrust control systems had to work with millisecond precision. One single error could cause a catastrophic failure. Over 400,000 people worked on the Apollo program, including NASA engineers and scientists, private companies like North American Aviation, Boeing, and Grumman University researchers, hundreds of subcontractors. In short, that one small step to the moon was actually the collective step of 500,000 people. Economic reality, the cost of Apollo. The Apollo program is the most expensive scientific project in human history. Its total cost, in 1973 dollars, was approximately $25.4 billion, equivalent to over $250 billion today. That accounted for about 4% of the total U.S. federal budget at the time, meaning that 1 out of every $25 the country spent went toward reaching the moon. So where did this enormous budget come from? The answer is simple: Cold War fear. The U.S. government believed that if the Soviet Union gained superiority in space, it would mean not just prestige, but a potential military threat. Every satellite launched into space could be seen as a potential spy eye or a nuclear missile platform. That's why the investment in Apollo was justified both as propaganda and as defense. However, after reaching the moon in 1969, much of the public began asking, so what now? The Vietnam War was ongoing, inflation was rising, and domestic unrest was spreading in the United States. For many Americans, going to the moon was no longer a source of pride, but a symbol of waste. The scientific data obtained were not enough justification for politicians of that era. Political dynamic, Kennedy's dream, Nixon's reality. When John F. Kennedy was assassinated in 1963, the moon goal was only halfway there. His successor, Lyndon B. Johnson, continued the project. But the real change came during Richard Nixon's presidency. Nixon wanted the moon landings to remain as America's victory story, but the billions of dollars needed to continue the program no longer had political support. The Nixon administration claimed that space has already been conquered and cut NASA's budget by more than 50%. At that time, polls showed that more than half of Americans believed the money spent on moon missions was a waste. Instead of trying to change this perception, Nixon preferred to make a glorious ending. Apollo 17 in 1972 became both the last moon mission and the closure of an era. Losses, accidents, and the human factor. Apollo was not only filled with triumphs. In 1967, during the Apollo 1 mission test phase, a fire broke out inside the capsule, killing 3 astronauts: Gus Grissom, Ed White, Roger Chaffee. The pure oxygen environment inside the capsule caused the fire to spread in seconds when the wires short-circuited. This tragedy taught NASA a lot. Safety standards were completely overhauled and test protocols were rewritten. But the incident also deeply affected the psychology within NASA. Astronauts were no longer seen as heroes, but as experimental test subjects. Every launch carried massive risks, both in terms of engineering and human endurance. The explosion during Apollo 13, Houston, we've had a problem, was the most striking example of that risk. When the oxygen tank exploded, they were 320,000 kilometers from Earth, with only a few hours of oxygen left. NASA engineers manually redirected all systems and miraculously brought the crew home alive. That event proved that the real miracle wasn't getting to the moon, it was returning safely. Public perception: what comes after the moon? After Apollo 11, each subsequent moon landing drew less attention than the one before. Television ratings dropped. Newspapers stopped putting moon photos on the front page. Going to the moon started to look like something ordinary. Ironically, humanity's greatest technological achievement became the victim of its own success. After a while, both politicians and the public began to see ideas like building a base on the moon or going to Mars as economically unreasonable. America was exhausted. From Vietnam, from the economic crisis, from social unrest. Every dollar spent on moon missions seemed like an abstract prestige project, detached from real-world problems. As a result, after Apollo 17 in 1972, NASA's moon program officially came to an end. On the night of July 20, 1969, the world held its breath. Billions of people watched Neil Armstrong walking on the gray surface of the moon on television. At that moment, humanity had set foot on another world for the first time. But ironically, only 3 years after that extraordinary achievement, the moon fell silent. Since the Apollo 17 mission in 1972, no human has returned to the moon. But why? The answer lies not in a single reason, but in a chain of interconnected economic, political, psychological, and scientific factors. Each mission after Apollo 11 struggled more and more to justify its cost as public interest waned. NASA's budget had peaked in 1966, reaching 4.4% of the total federal budget. By 1973, that figure had dropped below 1%. Each Apollo mission cost the equivalent of about $3 billion in today's money. That was an enormous burden for America at the time because the cost of the Vietnam War was rising rapidly. Social reform programs, especially the Great Society, required massive budgets. The oil crisis was approaching, and the public was asking, why spend money going to the moon when people are starving on Earth? NASA administrators struggled to find justification for continuing the program under growing economic pressure. Yes, the rock samples brought back from the moon were scientifically valuable, but for politicians, that wasn't a reason to spend billions more. Going to the moon was no longer seen as a useful investment, but as a romantic luxury. Apollo 11 was America's flag victory in the psychological war of the Cold War. The Soviet Union hadn't achieved a manned moon landing by 1969, so the US had completed its objective and won the space race. With that victory, the political purpose was fulfilled. President Richard Nixon in the 1970s shifted his focus to Earth rather than space. One of Nixon's advisors said at the time, "Going to the moon a second time won't excite the public as much as the first, but it will cost just as much." That sentence perfectly summarizes why Apollo ended. Projects that lose political value, no matter how scientifically important, are easily cut in Washington. Moreover, Nixon's administration wanted to focus not on the moon, but on orbit. This vision led to the birth of the Space Shuttle program in the late 1970s. But that new era also marked the beginning of the moon's forgetfulness. Landing on the moon, while technically possible, was not sustainable. Each mission required thousands of tons of fuel, hundreds of system tests, and tens of thousands of personnel. Even the longest stay on the moon, Apollo 17, lasted only 75 hours, about 3 days. Since the moon's atmosphere is almost non-existent, everything needed for survival had to be brought from Earth. Oxygen, water, fuel, food, radiation, protection, construction materials. Moreover, the lunar surface was constantly under threat from micrometeor impacts and intense radiation. With 1970s technology, establishing a permanent base under such conditions could not go beyond a dream. Yes, the moon was important for scientists, but compared to the billions spent, the scientific gain of these missions appeared limited. Many researchers began to say, "We no longer need to send humans, robots can do our work." This idea triggered the rise of unmanned space missions in the 1980s. Projects like Voyager, Pioneer, Viking, Luna, Chang'e, and Hayabusa came to the forefront during this period. In short, manned moon missions began to be seen not as scientific endeavors, but as romantic adventures. In the 1960s, the moon was humanity's unknown frontier. But after 6 successful landings, the veil of mystery was lifted. It was now believed that the moon had been scientifically studied enough. Rock samples showed that the geological structure was very similar to that of Earth. The composition of lunar dust supported the theory that the moon might be a fragment of Earth separated after a massive collision in the planet's early days. These discoveries were revolutionary, of course, but they also brought something else with them. The moon is no longer mysterious. NASA had great data, but the excitement was gone. The public no longer wanted to sit in front of the television and watch the same images again. In a sense, the moon lost human interest. No scientific achievement in history has ever been funded for long once public interest declined. The moon missions were no exception. After Apollo, NASA experienced a serious period of uncertainty. The agency turned toward new technologies with the goal of staying in space permanently. Reusable space vehicles, space shuttle, laboratories in Earth orbit, Skylab, later ISS, long-term robotic missions, Voyager Viking. This strategic shift completely changed NASA's nature. While the moon missions were one-time heroics, the new era was based on the idea of sustainable exploration. However, this came at the cost of the moon being forgotten. In NASA's internal reports, as of 1974, the following statements appeared. The lunar program has achieved scientific success. Our new priority is to establish a permanent presence in Earth orbit. These lines officially declared the end of the lunar era. One of the most interesting social phenomena that emerged after the Apollo era was the spread of the claim that we never went to the moon. In the late 1970s, these conspiracy theories argued that the moon missions never actually happened and that the footage was filmed in a studio. Although these claims have been completely debunked scientifically, for example, the laser reflectors placed on the moon's surface are still operational, they created a major image crisis for NASA. The fact that the moon had become not a symbol of heroism, but a subject of doubt further reduced public support. One of the reasons NASA could not find political backing to return to the moon in the 1980s, despite wanting to, was this atmosphere of distrust. Apollo 17 Commander Eugene Cernan said the following before leaving the lunar surface in 1972. Man's last step on the moon will also be the first step toward our return in the near future. But that near future lasted half a century. The moon program remained one of the greatest engineering achievements in history, but also became a symbol of humanity's longest pause. After Apollo, humanity kept looking at the sky, but never went back to the moon again. When the moon went silent, the space race was not over, but the nature of the race had changed. With the 1970s, space became less about going somewhere and more about being able to stay there. The magic of landing on the moon gave way to the idea of permanence in space. This transformation fundamentally changed the strategies of both NASA and the Soviet Union. When the Apollo program ended, NASA had an incredible accumulation of technology, but no clear goal. Going to the moon had been at the core of the agency's identity. Once that goal disappeared, the question arose, so what do we do now? In the early 1970s, NASA began searching for a new vision. Permanent bases in Earth orbit, Skylab. Reusable space vehicles, Space Shuttle. Deep space explorations, Pioneer, Voyager. But none of these goals were as striking as landing on the moon. Support in Congress declined, budgets shrank, and public interest waned. NASA entered one of the biggest crises in its history. Launched in 1973, Skylab was America's first space station. It was built using rockets and equipment left over from the Apollo missions. Weighing about 77 tons, this massive module was visited by 3 separate crews and hosted humans for a total of 171 days. Skylab proved that humans could stay in space for long durations after the moon. Astronauts there studied muscle and bone loss, conducted solar observations, tested the effects of microgravity. But it also revealed something else. Staying in space was far more challenging than going to the moon. Issues like damaged solar panels, food shortages, radiation effects, and psychological strain helped lay the groundwork for future space stations. Skylab burned up in the atmosphere in 1979, but manned spaceflight had entered a new era. By the late 1970s, NASA decided that the only way to maintain a lasting presence in space was through reusable systems. Throwing away giant rockets after each launch was not economical. The solution was a vehicle that could fly again and again. Thus was born the Space Shuttle. The first shuttle, Columbia, was launched on April 12, 1981. It was the first moment humanity traveled to space by bus. The shuttles, Columbia, Challenger, Discovery, Atlantis, Endeavour, could be reused multiple times, carry satellites, conduct scientific experiments, and build parts of space stations. The Space Shuttle program carried out 135 missions over 30 years, but these successes were also overshadowed by major tragedies. The 1986 Challenger disaster exploded 73 seconds after liftoff, killing 7 astronauts. The 2003 Columbia disaster, the heat shield was damaged during re-entry and the vehicle disintegrated in the atmosphere. These two events once again reminded humanity that space exploration required not just heroism, but risk and sacrifice. The shuttle program was technically impressive, but costs were still enormous. Each flight cost as much as the moon missions. The goal was cheap access to space, but in reality, space was still the luxury of billionaires. While the US was sending humans to the moon, the Soviets took a different path. The Soviet moon program's N-1 rockets failed 4 times, each ending in explosions. But the Soviets didn't give up. They built their strategy on permanence. In 1971, they built the first long-duration space stations with the Salyut series. Salyut 7 became a milestone by hosting humans for 237 days. Then in 1986, the legendary Mir space station was established. Mir operated for 15 years, orbiting Earth 28,000 times. The medical, physical, and biological experiments conducted there laid the foundation for the future International Space Station project. Soviet strategy was different from that of the United States. They chose to stay in space rather than just go to the moon, and they achieved this with remarkable success. By the late 1980s, the Soviet Union was weakening and finally collapsed in 1991. This completely changed the nature of the space race. It was no longer about who gets there faster, but how can we stay there together. In the early 1990s, the United States, Russia, Europe, Canada, and Japan came together to launch the International Space Station ISS project. This became the most comprehensive engineering collaboration in human history. 15 countries, 100,000 parts, 400 tons of modules, over 20 years of construction. The first module of the ISS, Zarya, was launched by Russia in 1998. In the following years, the US added Unity, Europe added Columbus, and Japan added Kibo. The ISS remains active today as humanity's longest-lasting presence in space. This collaboration proved that even after the Cold War, space could be a field of scientific cooperation, not competition or warfare. Although sending humans back to the moon was no longer a priority, space exploration continued. During this period, robotic missions carried data from the farthest reaches of the cosmos. Voyager 1 and 2, 1977, the first human-made objects to leave the solar system. Galileo, 1989, mapped the Jupiter system in great detail. Cassini-Huygens, 1997, delivered revolutionary data about Saturn and Titan. Mars Pathfinder, 1997, the first mobile robot to land on Mars. These missions proved that unmanned exploration could sometimes be more efficient than manned missions. Robots could travel millions of kilometers, operate for years, and carry no risk to human life. NASA's new strategy became clear. Instead of returning to the moon, let's explore the boundaries of the universe with robots. Between 1981 and 2011, the Space Shuttle era formed the backbone of human spaceflight. The shuttles carried 355 people into space, deployed telescopes, repaired satellites, and assembled the ISS. But each mission cost NASA over $450 million. True sustainability was still out of reach. The most significant scientific achievement of this era was the Hubble Space Telescope. Launched in 1990, Hubble provided incredible insights into the age of the universe, the structure of galaxies, and the nature of dark energy. In a sense, by not going to the moon, humanity learned to see much farther. By the 2000s, the moon had become a nostalgic memory, but a quiet change was taking place in the scientific world. A new generation of engineers and scientists began to ask, why aren't we going back to the moon? This time, the answer wasn't about pride or rivalry. It was about strategy and survival. The discovery of water ice at the lunar poles opened new possibilities for fuel production and life support. Moreover, the lunar regolith, moon soil, was found to be rich in helium-3, a potential fuel for future nuclear fusion energy. A resource so valuable it could redefine global energy systems. Suddenly, the moon became a scientific goldmine again. But this time, NASA was not alone. New players entered the scene: ESA, Roscosmos, China's CNSA, Japan's JAXA, and a rising generation of private space companies. When Apollo 17 departed the moon in 1972, most NASA engineers believed that wasn't the end, merely an intermission. In fact, spacecraft for Apollo 18, 19, and 20 had already been built. Yet unexpectedly, those missions were canceled. Behind the cancellations lay not just financial issues, but also politics, economic crises, and strategic redirection. In the 1960s, NASA symbolized American pride. But by the 1970s, it had become a luxury expense. NASA's budget, which peaked at $5.9 billion in 1966, roughly $60 billion today, fell below $3 billion by 1974. The problem wasn't just less money, it was where the money went. Congress refused to fund lunar programs, redirecting resources to national priorities, such as defense, economy, energy, and welfare. Under Nixon, NASA was told bluntly, space is no longer the priority, Earth is. That policy shift shaped NASA's next 30 years. The focus moved from one-time heroic missions to sustainable and cost-effective projects. Ironically, however, this drive for low costs would strain NASA even more over time. Apollo 18, 19, and 20 were officially canceled between 1970 and 1972 due to the financial burden of the Vietnam War, declining public interest, political pressure within NASA. Apollo 18 was supposed to land in Copernicus crater, a geologically rich region. Apollo 19 and 20 were to explore the moon's far side. Had those missions occurred, our understanding of the moon could have doubled. NASA redirected remaining hardware into other programs. Some spacecraft were placed in museums, others repurposed for Skylab. The Saturn V rocket built for Apollo 20 was used to launch Skylab in 1973. These cancellations deeply demoralized NASA's workforce. The agency's staff fell from 400,000 to about 70,000 within a few years. Politics, not engineering, became the main force shaping NASA's direction. Every major project required congressional approval, which made space exploration a bargaining chip in political games. In the 1970s, Apollo's cancellation was publicly justified as a budget issue. But behind the scenes, some senators claimed, the moon program distracts people from Earth's problems. It wasn't just about money, it was about public perception. Moreover, NASA had become a civilian agency, not a military one. That meant it no longer received backing from the Pentagon, which had funded much of its early research. This separation strengthened NASA's independence, but weakened its financial base. By the late 1970s, NASA shifted focus toward space shuttle development, believing staying in orbit is cheaper than going back to the moon. The goal was simple, to make space accessible with a reusable vehicle. But things didn't go as planned. The first launches were impressive, but the shuttles required extensive maintenance after every flight. The system that was meant to be cheap ended up being expensive again. The shuttle program effectively overshadowed lunar return plans. NASA's resources went toward shuttle maintenance, orbital experiments, and ISS construction. Even when lunar missions were reconsidered, they were postponed due to budget limitations. As one NASA administrator said in the early 2000s, the shuttle program kept us in space, but it stopped us from reaching the stars. NASA became a bureaucratic giant starting in the 1980s. Every accident, every failure, brought new layers of regulation and oversight. After the Challenger 1986 and Columbia 2003 disasters, safety procedures became so strict that innovation nearly came to a halt. Once the Apollo engineers were fearless pioneers who dared to fail. But by the 1990s, NASA had turned into an institution that feared failure itself. That difference slowed progress dramatically. Plans to return to the moon were drafted again and again, but rarely acted upon. 1989, George H.W. Bush. Space Exploration Initiative, 2004. George W. Bush. Constellation Program, 2010. Barack Obama. Constellation canceled, 2017. Donald Trump. Artemis Program launched. In short, NASA spent nearly 3 decades saying, "We'll return to the moon," but never did. Each president announced a new vision for space, and the next administration canceled it. This lack of continuity became NASA's greatest enemy. From the 2000s onward, space exploration was no longer the domain of governments alone. New players entered the stage: SpaceX, Elon Musk; Blue Origin, Jeff Bezos; Virgin Galactic, Richard Branson. These private companies operated outside NASA's heavy bureaucracy, developing faster and cheaper systems. In particular, SpaceX's reusable Falcon 9 rockets completely reshaped NASA's budget and strategy. Now, instead of building and owning every rocket, NASA partnered with private companies. This lowered costs and accelerated innovation, but also diminished NASA's role as a state-led pioneer. In this new era, NASA became more of a coordinator than a sole explorer. Let SpaceX handle transport to orbit, and I'll manage the mission to the moon. Efficiency rose, but the romance of exploration faded. The Artemis program was born from this balance, NASA's first attempt since 1972 to send humans back to the moon. Its name, inspired by Greek mythology, carries symbolism. Artemis was Apollo's twin sister, representing a new beginning. This time, the goal isn't just to send men, but the first woman and the first person of color to set foot on the moon. Artemis consists of three main stages: Artemis 1, 2022, uncrewed test flight, successfully completed; Artemis 2, 2026, crewed lunar orbit mission; Artemis 3, around 2028, first human landing since Apollo, but delays are inevitable. Each launch costs roughly $4 billion, and the total program could reach $100 billion. This revived an old question: is the moon still an expensive dream? The difference this time is that NASA isn't alone. It works alongside ESA, JAXA, the Canadian Space Agency, and SpaceX. For the first time, humanity is returning to the moon together. The reason we didn't go back in the 1970s wasn't cowardice. It was the logical outcome of its time. Economic strain, political games, technical limits, and waning public interest all combined to push the moon aside. But that pause made NASA mature, structured, and sustainable. If Apollo was a youthful dream, Artemis is an adult vision. Now, NASA's goal isn't just to reach the moon, but to stay there. Perhaps humanity's 50-year delay isn't a setback, but a necessary evolution. Because this time, the return to the moon will not be an end. It will be a beginning of permanence. When humans left the moon in 1972, many thought that era had closed. Yet in the 21st century, the moon has reemerged as a strategic and economic frontier. And this time, the stage is far more crowded. The United States, China, Russia, Europe, Japan, India, and private companies all share one goal: to establish a permanent presence on the lunar surface. This new chapter tells how the moon transformed from a symbol of exploration into a resource base and energy hub for the future. China's CNSA has been methodically building its lunar program since the early 2000s. Named after the moon goddess in Chinese mythology, the Chang'e missions form one of the most structured exploration plans in history. Chang'e 1, 2007, first Chinese orbiter around the moon. Chang'e 2, 2010, completed high-resolution lunar mapping. Chang'e 3, 2013, achieved a soft landing and deployed the U-2 rover. Chang'e 4, 2019, first ever landing on the far side of the moon. Chang'e 5, 2020, returned 1.7 kilograms of lunar soil to Earth. Chang'e 4 was historic. It reached a region no human-made object had ever touched. Because the far side of the moon is shielded from Earth's radio interference, it's ideal for radio astronomy and deep space observation. CNSA's long-term goal is to establish a crewed lunar base by the 2030s, powered by autonomous systems, 3D printing, and lunar dust construction. China's approach is quiet, but steady. Russia, after decades of decline post-Soviet era, began reviving its lunar ambitions with Luna 25, 2023. Its first moon mission in 47 years. The Soviet Luna program, 1959 to 1976, had achieved the first successful soft landing on the moon, Luna 9, 1966. But Luna 25 crashed during descent, losing communication before landing. Even so, Russia continued its plan. Luna 26, orbital mapping; Luna 27, ice exploration near the South Pole; Luna 28, sample return to Earth. In partnership with China, Roscosmos is developing the International Lunar Research Station, ILRS, a massive moon base planned for around 2035, designed to host both robotic and human missions. Together, Russia and China are forming a new lunar alliance. Meanwhile, ESA, European Space Agency, remains one of the most significant contributors, Even without sending astronauts directly, ESA's strength lies in collaboration, building components, modules, and systems for multinational efforts. Key ESA projects include Orion Service Module, provides power and life support for NASA's Artemis spacecraft. Smart One, 2003, first European spacecraft to reach the moon using an ion engine. Moon Village concept, a proposed multinational base at the moon's south pole, envisioned as a long-term research settlement. ESA sees this approach as the Antarctic model of space, a moon that belongs to no one, but serves as a shared field of research for all. The Indian Space Research Organization, ISRO, has made incredible progress in recent years. Despite limited budgets, ISRO has achieved great efficiency and taken major steps in its lunar program. Chandrayaan-1, 2008, discovered water molecules on the moon. Chandrayaan-2, 2019, failed during landing, but the orbiter remains active. Chandrayaan-3, 2023, became the first country to successfully land near the moon's south pole. This achievement placed India directly at the top tier of the Space Club. Chandrayaan-3 studied the moon's water reserves, providing essential data for future fuel and life support systems. ISRO's goal is to conduct a manned lunar mission by 2040. This mission could make India not only a space power, but also a global leader in energy policy. The Japan Aerospace Exploration Agency, JAXA, is one of the most innovative agencies in the world in terms of engineering. Its lunar programs are less known but extremely sophisticated. Kaguya, Selene, 2007, created a 3D topographic map of the moon's surface. SLIM, 2024, achieved meter-level precision landing using micro-landing technology, a world first. Japan's goal is to establish energy infrastructure on the moon within the Artemis program in the 2030s. JAXA plays a major role, particularly in solar energy and oxygen extraction from lunar soil. NASA is no longer going to the moon alone. It now has private companies and allied nations alongside. This is called the Artemis Accords. As of 2025, more than 30 countries have signed this agreement. Private companies' roles in the Artemis program include SpaceX, producing the Starship-based Human Landing System, HLS, Blue Origin, building lunar landers and logistical infrastructure, Astrobotic and Intuitive Machines, conducting robotic cargo missions. This system reduces NASA's financial burden while providing major opportunities for the private sector. Thus, state control is no longer the driving force. Market competition is. In recent years, all agencies, NASA, CNSA, ISRO, Roscosmos, JAXA, have focused on the moon's south pole. But why the same place? The answer: water, energy, and shadow. At the South Pole, there are frozen water ice deposits inside craters. Some peaks receive almost constant sunlight, and temperature differences are smaller than in other regions. Therefore, this area is ideal for permanent bases in terms of both energy and resources. NASA's Artemis 3 mission plans to land precisely in this region. Scientifically, water ice is the key to life on the moon. It can be used to produce oxygen. Combined with hydrogen, it becomes fuel. And most importantly, it enables the sustainability of human bases. Space is no longer just about science, it's about economics. The lunar surface holds the potential for $1 trillion industry in the future. Key commercial goals include helium-3 mining, an ideal fuel for fusion energy, regolith utilization, used as material for 3D printing and construction, tourism. SpaceX and Blue Origin plan tourist flights around the moon in the 2030s. Satellite and communication infrastructure. Networks similar to Starlink will be established around the moon. According to many analysts, the lunar economy could exceed $1 trillion by 2050. This marks the beginning of a new space economy revolution. The moon race has as much a geopolitical dimension as a scientific one. A silent power struggle is unfolding between the China-Russia alliance and the U.S. allied nations. It's a new version of the Cold War. Who will stay longer on the moon? Many countries are attempting to mark their own territory. This contradicts the 1967 Outer Space Treaty, which states that no nation may claim ownership of celestial bodies. However, building a base on the moon effectively implies ownership. Thus, in the coming decades, the moon will become the stage for new debates in science, diplomacy, and law alike. Today, we are looking at the moon again, but with different eyes. In 1969, we went there to be. Now we are going to stay. The moon is no longer just a relic of the past. It is the gateway to the solar system, a stopover for Mars missions, a hub for energy and resources, and a reflection of humanity's cosmic identity. Perhaps the reason we didn't return to the moon for 50 years was that humanity simply wasn't ready. But now we are. Because this time, it's not a single nation going. It's humanity itself. The moon, the only celestial body where every civilization on Earth has left its mark in the sky. Sometimes a goddess, sometimes a guide, sometimes a symbol of eternity. But on July 20th, 1969, the moon was no longer just in the sky. It became the center of human history. Neil Armstrong's famous step was not only that of an astronaut, but a new chapter in the evolution of the entire human species. Yet for more than 50 years, that chapter remained silent. Now that silence is breaking again. Psychology says every individual has a mirror stage, the moment of seeing oneself from the outside for the first time. For humanity, that mirror was the moon. Remember Apollo 8's Earthrise photo, a blue dot rising in the middle of dark emptiness. That image told humanity, we are not the center of the universe. We are its fragile part. Going to the moon was, in truth, rediscovering the Earth. Because for the first time, we saw our home from the outside. Perhaps that's why returning from the moon was harder than going there. The 50 years after Apollo were the years when humanity paused its own dream. Technology advanced, the internet was born, Mars was mapped. Yet the moon stayed silent. NASA, China, Russia, Europe. They all gazed at the sky, but no one set foot there again. That period was, in a way, the years of cosmic introspection. Humanity turned its focus not to space, but to itself. But this pause wasn't in vain. During that time, science matured, technology advanced, and human consciousness expanded. We waited, not to go back to the moon, but to stay there. Returning to the moon is no longer just an engineering achievement. It's a declaration of existence. Establishing permanent bases there means planting the seeds of a new civilization. NASA's Artemis, China's ILRS, India's Chandrayaan, Europe's Moon Village, all share the same goal. The moon will be Earth's first colony in space. But this is not merely a strategic move. A permanent human presence on the moon is also a redefinition of who we are. Because when we go there, we will bring not flags, but science, culture, art, and consciousness. Life on the lunar surface is not only a physical challenge, but also a psychological one. Gravity is 1/6, day-night cycles last 14 days, and radiation levels are deadly. Yet the human mind has always adapted to challenges throughout history. The new technologies developed for people who will live in lunar bases will also revolutionize life on Earth. Radiation-shielded living modules, oxygen and water production from lunar dust, closed ecosystem farming systems, structures built through 3D printing. So every system to be established on the moon will actually be a test for the future of Earth. Because one day Earth may become a place as difficult to live on as the moon. And what we learn there might save us. In the 20th century, space meant competition. In the 21st century, space means unity. NASA, ESA, JAXA, Roscosmos, CNSA, and private companies are now setting common goals. The first base to be established on the moon will most likely be an international research town. Just like Antarctica, a region belonging to all humanity in the name of science. The astronauts who will serve there will no longer be just Americans or Chinese, but representatives of humanity. This means the rise of our collective consciousness as a species. For the first time, as we cross the boundaries of our planet, we are learning to be allies, not rivals. The moon will become a mandatory stop on the way to Mars. NASA's Artemis Program and China's ILRS are, in fact, great rehearsals for Mars. The hydrogen fuel to be produced on the lunar surface will become the logistics center of future Mars missions. So one day, the ships traveling to Mars will refuel on the moon. From this perspective, the moon is not just a destination, but a bridge, a transfer station for humanity leaving Earth to reach other worlds. When we look at the moon now, we no longer feel alone, because we know we can really go there, and we will go again. Every Apollo astronaut said the same thing when they returned from the moon. When you look at Earth from there, you don't see countries, borders, or wars. You only see one planet, our home. The moon reminded us of one truth. We are not 8 billion individuals. We are one species, the children of a single planet. And now we are ready to go beyond that planet. History is cyclical. We went in 1969, we returned in 1972. Then we waited. Now we set out again. But this time, we are different. We are no longer humanity that goes to the moon, but humanity that will stay on the moon. Those steps will not only be footprints, they will be the seals of human mind, courage, and curiosity. Maybe 100 years from now, a child will look at Earth from a moon base and say, "This is where humanity began." And perhaps at that moment, the voice echoing across the silent surface of the moon will not be Neil Armstrong's, but humanity's own voice. This is a giant leap for our species. Returning to the moon is not really a comeback, but a rediscovery of our own nature. Because we are a species that questions, wonders, and dreams. When you look up at the sky, you don't just see a satellite there, you see yourself. The moon teaches us this: what seems distant is actually within us. 50 years ago, we set foot there for the first time. Now we will go again, but this time, not for a mission, for a legacy. The moon is no longer our past, it's the foundation of our future. Not returning to the moon was forgetfulness, but returning to it will be humanity's reawakening to its own consciousness. Because when we look at the sky now, we no longer see only stars, we see our own potential. And that potential marks the beginning of a journey that will last forever. So that's it, dear friends. That's all we have to say about the moon and the journeys made there. Now I'm off to prepare my next video, and while I do that, don't forget to subscribe to the channel, like our videos, and share your new video ideas in the comments. See you soon. Stay safe.